So this entire unit is called Systems of Linear Equations, right here. And what we're going to do in this first little lesson is I want to develop the system. Well, wait a second. Before I develop a system, I got to know what the heck a system of equations is. A system of equations is two or more linear equations with common variables. What does that mean? That didn't clarify anything now, did it? Yes, it did, because number one, you're looking at this. You're looking at an equation that is linear, kind of like y equals to 2x plus 5, and you're looking at another equation like 3x plus 7. And you're putting these two equations together. So in other words, there's something common to both of these. And you can see the commonality between them. They both have x's, they both have y's. If one of the equations was like y equals to 2x plus 5, and the other equation was a equals to 3b plus 7, then you got a problem. Notice that they're both contains x's and both contains y's. This is a system. They have a commonality to them. Now, also that they're linear equations, which means the exponent, the degree on these guys have to be 1. What do I mean by that? Look at the x here. That's to the power of 1. So is that one. Look at the y. It's a power of 1. So is that one. So both of these then are linear systems. They've got a power of 1. Now what does this mean? Well, now if you look at a linear system, we can actually solve this guy. So solving it becomes a solution. So we put the two lines together somehow, and that's what we're going to do later on. And we're going to find a common point to it all. What does that mean? We're going to find a point of intersection. And this point of intersection, like right here, if you noticed, is right there. What does that point of intersection mean? Well, that point of intersection is an ordered pair. So in this particular case, I can call this point -2, -3. And the cool thing is that this point suddenly now satisfies both equations. What does that mean? That basically means it's not only on this line here, but it's also on this line. X marks the spot. There it is. That thing actually satisfies this equation and that equation because it appears on both graphs. Cool. Okay. So a pair of values occurring in the tables of values of both equations. We'll get to that later. The solution of the linear system can be estimated, just like I did, by looking at the graph and saying, hey, that's my solution. That must be my point of, you got it, intersection. So what you can put down here now is this. The point of intersection is the solution. That's simple. So point of intersection is a solution. In other words, that's what we're going to concentrate this entire unit on, is finding that point. Wow. Okay, so let's go on here. So before we can do that, we have to be able to look at a statement and develop the system translating English into mathematics. And that's where a lot of people have problems. So that's why I want to go through a possible little scenario for you. And then the subsequent podcasts are going to have, guess what? We're going to try more different questions, and then eventually we're going to solve. So how do you develop a system of equations? That's the question. First thing, read and reread and reread a third time and reread a fourth time and reread a fifth time if you have to, and always try to underline key terms. That's the important thing. Try to find out what are the key terms that you're talking about it. Then translate the words into mathematics, recognizing keywords as operations. So look for things like and, which means plus, difference, which means subtraction, multiples of, timesing by. Okay, the word is means equals, and things like that. And with the questions that we're going to do here right away, I'm going to show you some pretty neat questions, and that might help us in understanding the translation part there. Then select appropriate variables. You don't always have to go with X's and Y's. You can go with things like, oh, if we're talking about money, we can put cost and the number of people. We can put n, and so on. We don't have to always go with x's and y's. Then establish the relationship. So in other words, this is where you're actually writing the equation out. And the solving part, Yeah, we're going to do in the next little chapter here. I'll show you how to do that eventually. I want to concentrate on developing the system now because I think that's what's really, really important. Okay, so here we go. Example number 1. It says the Smith family and the Jones family are going to a book fair raising money for charity. Okay, so far, if you think about that, there's really nothing there mathematically to translate. Okay, now here we go. Mr. Smith pays an entrance fee of $11 for 3 adults, and 1 child. That's important. Here comes our next part. It says Mrs. Jones pays an entrance fee of $12 for 2 adults and 3 children. There's our system. Let's talk about Mr. Smith. Okay, let's talk about Mr. Smith and what did he end up doing here. Mr. Smith pays an entrance fee of $11. That consists of 3 adults. Notice this is the second time I'm reading this. 3 adults. Well, wait a second. Let's choose a symbol for adults. Let's just use A. A standing for adults. So I have 3 adults. So 3 adults. Well, that was easy enough to do. And, what's the word and mean? Well, and means plus. 1 child, okay? Let's call children C. So this would be 1 child. So interpreting this, what I just wrote down, $11 is spent on 3 adult tickets and 1 child ticket. Oh, that's kind of easy. That's very straightforward. Let's go to the next one here then. The next one would be, now, this is Mrs. Jones who spends $12. Okay, so there's Jonesy. There it is right there. Jones is $12 equals to 2 adults now. Well, remember, adults was A. So 2 adults would be 2A. And there's the and, which means plus 3 children, 3C. And guess what? You've just developed your first system of equations. You have 2 linear equations. Everything's to the exponent of 1. You see it? Everything's to the exponent of 1. The A's are in common to both, the C's are in common to both, and everything is set up beautifully. There's a system. Now, eventually, I'm going to show you how to develop this system into an actual solving the equation. But I want to show you something really cool here. Look down here. Now that we've solved this, or I should say, now that we've developed it, look at this. It says try the following numbers in both your equations. Let's try an adult price of $3 and try a child price of $2. Well, let's call this one equation number 1, okay, which is the Smith equation. So equation number 1 says 11 equals to 3A plus 1C. Now, let's put in some numbers here. There's the adult price of 3. So that means this is 3 times 3 for each adult, plus the child price of 2, 1 times 2. Now, look at this. If you look at this and actually multiply them out now, 3 times 3 is 9, plus 1 times 2 is 2, and look at that. You actually end up 11. You actually get the price that she paid. Now, check this out. If we do the Jones family now, the Jones family says 12 equals to 2. What were the adult prices again? Oh yeah, 3, okay? 3 for the adult prices, plus the child prices here was, she's got 3 children, and the child prices here were $2 each. So put in 2. Let's see, 2 times 3 is 6, plus 3 times 2 is 6. Add them together, that gives you 12. Oh, look at that. They match. So this idea of 3 for the adults, 2 for the children satisfies not only the Smith family equation, but the Jones family equation as well. So guess what? That must be the solution to our system of equations. Adults prices is going to be 3. Child prices is going to be 2. And that's what this big statement over here says. It says values that work for both equations are called the solutions to the system. So how do you find these numbers? Well, that you're going to have to wait until you get into other podcasts. But for right now, all I want to teach you is how to set it up early.